Hi guys, Shouvik here. Welcome back to your YouTube channel. So today we'll solve another question from Leetcode itself. So let's get started. Yes, so today we have count good triplets. So this question is easy tech and I also like directly implement the brute. So first we will go through the problem statement, then we will discuss quickly on the intuitions building, and then we can do the code iterations, and then time and space complexity analysis for sure at the end. So yeah, so given an array of integers ARR and three integers ABC they have given, and you need to find the number of good triplets. What we have to find? The number of good triplets. A triplet is array I, J and K is good if the following conditions are true. What's the conditions? I, J, K should follow the ascending order or the increasing index patterns. So the index I you choose, J should be next, like at the right side of I, and K should be at right side of J. This condition should follow, and absolute of array of I minus J should be less than A, absolute of J minus K is less than equals to B, and I minus K is less than equals to C, where this denotes the absolute value of X. I guess you guys know about absolute. If you do minus abs of minus to any negative absolute is going to be turned to its positive value. So minus 5 absolute is 5, minus 3 absolute is 3, like this way. So return the number of good triplets. So that's all about the question. I think it's very straightforward, and why it is tagged as easy. What actually the very brute coming to your brain? We can run 3 loops, we can run 3 for loops, and on 3 for loops we for every I, J and K we can validate if this all 3 conditions is valid. If all 3 conditions is valid, then we can say this is a valid triplet. We can increase our answer. And if you can do this very brute, then also it is going to be accepted, because the constant is 100, and 3 nested loop is going to be take off n cube kind of complexity. So n cube 100 cube is going to be 10 raised to the power 6, which is under 10 raised to the power 8. So it's going to give you a for sure SE. So yeah, I not able to find out any optimizations of the brute, very frankly speaking, because the reason is when you are, let's suppose I am running a single loop on K, or let's suppose double loop to basically fit J and K, and every relations is linked to everyone. If I guess if you are not able, I'm not sure if you guys have already seen a video where we have find similar kind of patterns of triplets of that problem we have sort of big of it, but there the condition is something like we just have to think about the last visited. If we have the liberty of considering the last visited ones to play, then we can play, like we can think of at least some optimizations. But here you can see, like I is dependent on J is dependent on K, and again I is going to be dependent on K. So every I, J, K, every 3 is linked somehow dependent of another 2. So in that case, I don't think any further optimizations is going to be work. But yeah, definitely guys, if you guys are able to find any optimizations, like are able to solve it kind of big of n square or n cube, less than of n cube, big of n square kind of complexity, then please like big of n square or lesser like that, then though like it's super good. Like any big of n cube lesser complexity, then please guys, please make a comments, and please share your idea to the comment box, so that would be going to help others also. Yeah, so I am not going to go any one note today, because I just write the exact brute, just one small optimizations I did, but yeah, that is not going to make a time complexity bigo level optimizations, but on intuitions based it's kind of optimizations you can say. So yeah, I took in len of array, and I initialized my answer to be 0, and then I started 3 nested loops. I should be from start to n, J should start from I plus 1 to n, and I am, so that is the optimization I just put. If all together, so when I and J I have pointed out, when I have ready with my I and J pointer, then before starting my K pointer altogether, I am just checking if my absolute of I minus J is less than equals to A altogether. So that is the very first case. If that is altogether going to be satisfied, then I am happy to start a K loop. And if that is not, then I am not performing the K loops altogether. That is a kind of optimizations, but on bigger complexity, you have to tell it is a big of n cube. There is no optimizations we are able to put, because I guess you guys are able to identify if for every index this conditions is going to be satisfied, right? Because for every index, if it is going to be satisfied, then K loop is going to be run for every time, and the very standard iterations boundary for K loops, K start from J plus 1 to n, and for if we have 3 pointers ready, I, J and K, then I, J we have checked initially, then just do a check for JK should be less than equals to B, and IK should be less than equals to C. Yes, if all 3 valid, then increase your answer. and finally return your answer. So the question is as simple as that, like on brute perspective. And I am pretty sure like further optimization is not possible altogether, but yes, I'm very happy to like going to get any further optimization comments if you guys are able to make so. Yeah, so on time complexity, it's nothing like of big of n cube, standard big of n cube. And on space perspective, there is nothing, we are not using any extra space, so on space perspective it is constant. So that's all about on today's questions, guys. And yes, if you guys are able to understand, please I will suggest, please share the videos to your connections, because that is like, if your connections are also going to prepare for top product based company and they are also want to brush up their DSL skills with industry standard problem, they can also get most of it. And please subscribe to our channel, and you have to do one more thing, like please turn on the notification so that when we are going to live with our next video. So that's it, guys. That's it for today. Bye, guys. Let's meet tomorrow with another beautiful question. Bye bye.